Experiment 2 is about density, but our objectives for each experiment include some definitions that are just important to the chemistry class as a whole. So we hit some of these in lab as well. So starting with the definition of matter, anything that occupies space and has mass. And the next two definitions have to do with types of substances. Substances, for chemists, substance means pure, they're not mixtures, and there are only two types of substances. There are elements and there are compounds. Elements cannot be broken down into simpler substances, and the way we represent an element with its elemental symbol, something like this. I know that this is a symbol for just one element because the first letter is capitalized and the second letter is lowercase. Of course, if an element symbol just has one letter, it's capitalized. I should mention also that something like this also represents an element. It doesn't matter that there are two atoms of that element in the particles. That is still an element because there's only one element symbol there. Compounds have two or more elements that are chemically combined. So you can recognize their chemical formulas because they have more than one element in them. Okay, those are chemical formulas that represent elements or compounds. Now let's talk about the particles of matter, and we'll talk about atoms versus molecules. Atoms are the smallest unit, and so this formula represents one atom, this formula represents one atom. They don't lose their identity in a chemical reaction. A molecule, so we can use formulas to represent molecules as well. So this is a molecule because it contains 5 atoms that are bonded together. The particle is the molecule. The type of matter it is a compound because it has more than one type of element there. This is also a molecule. This is a molecule of the element hydrogen. So it is both a molecule, the type of particle, and the type of matter is element. Organic compounds are carbon-based compounds, so anything with carbon in them, we just look for that carbon. That's a simple definition, but that's easy. Sometimes people think that water is an organic compound because it's in living things, but it is not. It is not carbon-based. Inorganic compounds are compounds that don't contain carbon. So water, this is ammonia. Anything we don't see carbon in it, no C's, so it's inorganic. An acid is something that produces hydrogen ions when it dissolves in water. And so, in other words, they normally will be written so that their first letter is an H. When we put this in water, it breaks apart into ions, like this. So because it produces hydrogen ions, that's an acid. A base produces hydroxide ions in water. Sodium hydroxide is a base. Since it produces hydroxide ions when we put it in water, it's a base. A salt is an ionic compound. That's how we'll call it, what we'll call it for most of the class, that is the product of a neutralization reaction. So acid plus base yields salt plus water. We'll talk about that more a little bit later, but for now you need to know it's an ionic compound. Ionic compounds mean you have a metal and a non-metal combined. Metal and a non-metal come together to make a salt, and it doesn't have to be sodium chloride, of course. This is sodium bromide. Sodium's a metal, bromine's a non-metal, so that is a salt. An oxide is just a binary compound containing oxygen. Binary means that it has two elements, and one of them is oxygen. On oxides, the oxygen will be second in the formula, so that is a copper oxide. This is an oxide. This is an oxide. Pretty easy to spot those. And then we get to our last definition, which is what we're going to deal with for our lab today, density. Density is mass divided by volume. In layman's term, we think of that as how heavy it is. That's how we experience it anyway, how heavy it is for its size. In other words, when you go to pick up an object, if it surprises you by how heavy it is for its size, it's because it's more dense than you expected. An important thing about density is that it's an intensive physical property. That means density does not change depending on how much your sample is. In other words, like if you had an ounce of gold, that would be like a gold coin of some sort, a small gold coin, versus a pound of gold, that would be maybe a small bar of gold, be larger for sure. Which one is more dense? Well, they have to have the same density because they're both gold. This one has a smaller mass, but it also has a smaller volume. And when you divide mass by volume, you'll get the same number as in the larger bar of gold. That's going to help us when we do our experiment.